This is question 10 from the GATE 2020 EC paper, where we are asked to find what the equation of the output F of this combinatorial circuit, that is this multiplexer, is of the input variables P, Q and R. Some of the inputs are tied to P and Q, some of them are tied to R, and some of them are tied to logic levels 0 and 1. Below the question description, you can find the title of the NPTEL video and course that is relevant to this question. So let us attempt solving this question. First, a little bit of background on what a multiplexer is. A multiplexer is a combinatorial circuit that accepts 2 power n inputs and n select signals, which are also inputs, and has one output. As the diagram suggests, the purpose of the multiplexer is to simply pass the selected input, let's say Sn minus 1, Sn minus 2, so on till S0, that is the select line. Let's say this was equal to 0, 0, 0 and then 1, right? If this was the select signal, that is, it corresponds to the binary to decimal converted to it corresponds to 1, then we would choose I1, that is this short would be placed on I1, which is indicative or figurative of saying that I1 is passed to the output. That would mean Y is equal to I1, right? So you can see the truth table for an 8 input 3 select line mux. If I were to have chosen 0, 0, 1, then output would be I1, and so on and so forth for various other inputs. Now, with this as background established for a multiplexer, we can go ahead towards solving the problem. So the problem describes a multiplexer connected with various digital inputs for the select and input lines, and we are asked to find out which one of these four is the actual equation of F as a function of P, Q, R. Now let's look at the truth table for the logic circuit. The truth table is as below, but let's see how we build that. If I were to place 0, 0 on the select lines, then I'm choosing, now this is in digital, it's in decimal, it's 0. So I'm choosing I0, right? So just put the decimal value as the subscript and you will get which input was chosen. So I am choosing I0, right? Which is to say F is equal to R. R gets passed. And thus I placed an R at the output. Similarly for 0, 1, 0 would get passed. And I placed a 0 here. And 1, 0, again, since R is placed at I2, F would be equal to R. And so I placed an R here. And this is how I built the truth table for 1, 1 as well. Now, with the truth table built, you can clearly see that if Q is equal to 1, right, whenever Q is equal to 1, then F is equal to P. It was 0 here and it's 0 here. It was 1 here and it's 1 here. And if Q is equal to 0, right, if Q is equal to 0, then F is equal to R, right? So we can conclude that F is equal to PQ bar plus Q bar R. PQ, sorry, not Q bar, PQ plus Q bar R, which is of course the option A.